So here we are again with another podcast. Let's take it off. Intelligent Materials and Systems Lab is online, and we have Karl and Human joining us. Human is a fresh doctor, defended the dissertation on a really fascinating topic that I tried to read the conclusion. Given the status of a rookie, I will lean on you guys as experts to explain in depth what the dissertation was about.
So my thesis dealt with the problem of how we can actually move a robot from point A to point B by taking into account some of some constraints. Like, for example, you want to move your robot from one point of the room to another point of the room, but you want to have a specific part of the whole area in your field of view while you're moving. And my thesis deals with such problem of how you can move your robot in this manner while avoiding the obstacles in the environment. Because if you want to do this in an environment which has a lot of obstacles, it might not be a really easy task, because sometimes there are obstacles that would come and block your view. Therefore, you have to avoid the obstacles in a way that you achieve your task and also avoid blockage of your own view as well.
So, Karl, do you think this was a correct and a satisfactory way of describing the dissertation to a 5-year-old?
Well, if you're emphasizing the fact that it has to be explained to a 5-year-old,
no,
then obviously not.
My point of interest would be, you as a supervisor, where do you see applications for such knowledge?
Well, there are two sides to this question. One is the fact that when we're talking about robotics development and how it can be applied, so your first very obvious application areas is like, if a robot possesses this capability, and Human described this capability where a robot is able to track a certain object and then autonomously navigate through some space that might have obstacles in, then there are different examples that can be brought. In the thesis itself, he's mentioning aerial cinematography, collaborative robots, where one robot constantly has to see the other robot. So you have these application areas. But like I said, there are two sides to this. And the second side is like the technology and the advancements that Human made in his thesis. These can actually have a broader impact. For instance, we can apply the developed methods wherever we need very fast, reliable robots making decisions while they have relatively reserved computational performance available.
Well, I can give you a very direct example of that, which actually influences your work quite a lot. You're now the one actually interviewing us, so your work mostly revolves around film and cinematography. So there might be situations that you want to actually keep filming a person while giving this a stunning shot actually will happen if you actually can avoid the obstacles in a nice way, that throughout the whole movement that you're capturing a person or a shot, your field of view will never get occluded or will never get blocked. Therefore, my work actually influences your work quite directly, so that you can get this autonomous fancy shots without actually being teleoperating for example, a drone or a robot yourself. For example, you would use a drone to capture a person, but then you have to teleoperate it yourself. However, if you run the algorithm that, for example, I developed in my thesis, that work can be done autonomously without any human intervention. Commercial solutions are already out there by some of the vendors. However, the very thing that we developed in our thesis was you don't have to go for a special kind, for example, a drone. You can actually get any drone and implement our algorithm on it and get it actually autonomous. But for example, if you want to rely on a very specific brand, then that might have been a problem. Maybe for example, let's say that you want a drone which has a really good camera, but it doesn't have that functionality. So you have to go for another brand which has that functionality, but might not necessarily have a good camera to capture the images. So you would get the drone which has good image quality or camera, and then you implement our own algorithm on it, and voila, there you go.
Okay, so you would help the industrial revolution come along.
I guess at least in the field of robotics is pretty valuable if you can open source your problem, because your solution, because there are a lot of stuff that has been already there, but because they are proprietary, you cannot actually see their you have to either pay a lot for them, or sometimes you are actually limited because they are proprietary to one single company. But if you actually can develop the same thing and open source it, then the whole world can use it. So I would say that this is one of the biggest advantages of this research that has brought this same functionality. It might be the same as what the other company or what other robot manufacturer provides. However, our solution is open source. Anybody can use it.
So you guys are scientists, and from the dissertation, defense of the dissertation, I heard a fun fact that you described how you needed to get accustomed to new research coming out every 2 or 3 months, and you had to like rewrite some stuff and rethink some modeling.
When you do research, at least in the area of robotics, you have to compare your whatever you develop to the state of the art. You cannot necessarily develop what other people have developed, so you want to improve upon that. And one way to actually see whether your algorithm is good enough is to actually compare it with the state of the art. However, many of the state of the art algorithms might research might not necessarily open source their solution. So they might have a really fancy good algorithm, but because they have not open sourced their solution, we cannot use it. So we are trying to actually kind of bridge this gap, both bringing this solution and also open source it so that other people can also use it. And and be as good as the whatever is currently available or better than that.
How rare of a doctoral student was Human for you to supervise, Karl?
Well, Human is one of the rarest of students at all. It does, because our collaboration started already when he was a master's student, and back then he very quickly impressed everybody around him, not just me. He's very dedicated. He's super motivated. He's trustworthy, reliable. So a lot of things were so easy with him, because basically you never have to say anything twice to this guy. So I think he's a good role model to any engineering student, but it would be unrealistic expectation to say that everyone should be like him.
Mm-hmm. So you would point out some academic virtues, and would you say that in general your robotics and engineering students carry the same value package, or what game do they bring on the table when they come to the masters or the doctorals?
Oh, this is very hard question to answer, because the reality is that students are so different, and I think this is the thing that to me as a supervisor is most exciting about my work, is that I get to work with these different people from different cultural contexts, but more interestingly, even more different technical contexts, and discovering what are their strengths and how this can be of value whichever engineering project we undertake. So this is an amazing experience, and it's impossible to say what a specific student brings. It's the whole package.
Human, how would you comment on this? Would you say that the Institute of Technology helped you blossom in the direction you were thriving towards?
Yeah, definitely. So the very first year that actually I started working with Karl on the second year of my master's, and I think I was so fortunate to actually go to him and actually started this collaboration with him. And one of the University of Tartu might seem a very small university, but I guess there might be pros and cons to that. But however, I think the pros actually overweigh the cons. So for me, because as I ventured into the lab, I was fortunate enough to see a lot of projects coming to the lab, and I tried to be part of those projects, and being part of those projects helped me gain experience in different aspects of robotics. And all together, I'm happy that this variety of experiences, I have managed to get this variety of experiences by the end of my PhD degree. So maybe initially when I started my PhD, I was actually a little bit skeptical about what I would be doing. Would it be completely theoretical, or it would not have like any industrial applications, or it would not be applicable to the current environment. However, that didn't turn out to be like that, and most of my work is happily being integrated and deployed on actual robots, which you can actually right now start using them, and they're pretty tangible.
So, as I understand, you yourself work at Janu.
Yes.
And this is, to be known, a project that was helped to life by one of our professors, Alvo Aablo. And would you say you feel his caring touch somewhere between the lines of code and between the wires of hardware?
Yeah, so I would say that this project was brought into life by both him and Carl together. So actually, one of the very first important projects that I was engaged in was the project of Janu. So initially, when I came to the lab, another person was working on that, and I was actually, in the very beginning, I was fascinated with that. And I went to Carl, and that person actually graduated and moved on to a different career. And at that time, I asked Carl, can I join this project? And Carl happily accepted that. And I was so happy that I started taking over this responsibility. And yeah, I guess that was partly one of the turning points. And I'm quite happy that I've been part of it, and has helped me quite a lot.
Carl, would you comment on that? Was it like everyone won from this situation? Or?
Yeah, definitely. This was a win-win-win-win situation for all the interested parties. And I think, of course, the biggest winner here was Human, because in robotics, there's very often happening one out of the two things. Like you're very excited to work with the physical robots, and you end up more on the engineering, on the applied robotics side, and then there can be people out there, especially in the research domain, who say like, but you're not contributing enough in terms of like pushing the bleeding edge of robotics forward in terms of research. Human was fortunate enough to have the two roles combined. So he was, as a PhD student, able to work on these very hard research problems in robotics and push the bleeding edge there, whereas this industry-driven project for Janu kept him 2 feet on the ground in terms of engineering, knowing what it actually means to make a robot move in real world. And he very well managed to balance these two things eventually in his PhD dissertation. So I think that's definitely a virtue of his thesis.
And that's also, I would say, a success story of the Institute, that it shows that you have the theoretical and the practical side of the academia going hand in hand. I think Janu is really pushing the boundaries. They have already reached like international markets and stuff like that. I've heard they're already in Saudi Arabia or something like that. So it's really, really crazy to see how engineers help basically Estonian companies to reach such amazing scales.
I mean, this is what we are actually very much going for in our robotics and computer engineering study program. And it's not an easy task to undertake, because I think every university that develops the next generation of engineers has this constant internal conflict within them. Because on one hand, you're expected to make sure that there's a new generation of robotics researchers, new generation of robotics professors out there who can be at the universities teaching robotics. At the same time, there's a huge demand on job market. Startups, big tech companies, they want staff. And now, if you're 20-something master student, you enroll at a university and you have to make that decision whether to become an engineer at, I don't know, Tesla, or become a professor at a university. It's not an easy choice to make, and you might not even know at that stage which choice you want to make. And now a study program has to cater to both of these needs. And this is challenging. This is extremely challenging, and this is part of the reason why sometimes in media you might hear voices saying that, oh, that university does not offer a practical education, or that other university is too applied and they don't have leading value in innovation or something like that. So you would hear these things, but in reality that's just showing that there's always these two parallels going on at the same time. And I think at University of Tartu, I'm not saying that we have figured it out how to do this, but we at least acknowledge that this duality exists, and we are constantly trying to help students with both tracks, both the academic track and the engineering track.
Human, could you describe a dystopian future where AI gets out of control and your dissertation is the route for evil drones hunting us down?
So if I want to be honest, I do believe that there's gonna be a robo-apocalypse, if I want to be honest. And I don't mind it. I don't mind being a part of that. And at some point I'll be a cyborg, but I don't think if it's good to put it in this podcast, to be honest. But I would say that maybe something along the lines of this industry 6.0 that previously we had, we had different levels of industry revolution coming from 1.0, 2.0, and then we reached at some point to 5.0, where they wanted everything to be automated and having all the humans out of the loop. However, after some time they understood that we're not still there and might not necessarily be good to have the human completely out of the loop. So we can automate some part of the work, but we still want the human to be there and actually leverage that as well. So humans working together with collaborative robots to enhance the result of a work, for example. And I guess whoever develops stuff, so that would be the very first thing that comes to any normal person, that robotics would remove or eliminate many of the jobs in this future. And that's partially true. Yes, it definitely removes many of the jobs, but it does create some other jobs as well. And at some point, I guess we would reach a level that even if anything is being done by the robots, then right now we're paying for services, but maybe even everything is being done by the robots, then there's no need to pay for many of the services. So there's a silver lining to that as well.
We have a new building. We'll have another new building in a couple of years. So what will be the premise of that? What will be the future for engineering students in the University of Tartu? What do you think?
The future always is brighter. So that's the thing. We're getting new buildings. That means more space for our learners, more space for our robots, more creative spaces where students of different disciplines can interact.
I'll definitely try to be in touch and even do stuff remotely. Yeah, I've learned a lot in here, and I'll try to keep my connection as much as I can.
And the final question for you guys: will we see autonomous robots roaming around in the new building in the near future?
Well, obviously there will be some autonomous robots constantly roaming around, simply because there are students who work on developing those robots. But if you're asking, will the new building already be some sort of a wonder house with robots around, then here I have to be a little bit more skeptical and say that probably not. Yeah.
Well, some hope remains, so we'll live and see, and join us next time. Bye, guys.